This is Notes 3-5, Simplifying Square Roots, Day 1. There are different methods for simplifying square roots. The first one we're going to look at is prime factors. So I'm looking at what's under my radical, or under the house, and I'm going to find all the prime factors using a factor tree. 48 could be 6 times 8. We know that 6 breaks down into 2 and 3. 2 and 3 cannot be broken down anymore. There's nothing that multiplies to be 2 other than 1 in itself. And same for 3, so those are prime. 8 is 2 times 4. 2 is prime, and 4 is 2 times 2. So I know here that 48 is the same as all of my prime factors. I have 1, 2, 3, 4 2's. And 1, 3. And I'm going to carry down this 2 that was outside my radical, that multiplier. Now that I have my prime factors, I'm looking for pairs of prime factors. Here's one pair. Here's another pair. My pairs of 2's, it's like they get married, they leave the house, and they become 1. So here's one from my first pair. My second pair gets married, leaves the house. Here's his, and it becomes 1. The 3 was lonely. He doesn't have a match, so he has to stay inside the house. Don't forget to carry down whatever number was in front of your radical. Now all that's left is for me to simplify. I multiply together everything that's left on the outside. 2 times 2 times 2 makes 8, and I keep my root 3. So my simplified answer is 8 square root of 3. Alright, moving on to number 2. 72, if I'm breaking it down into primes, I know that 72 is 8 times 9. 8 can be broken down into 2 times 4. 2 is prime, and 4 can be broken down into 2 times 2. 9 we know is 3 times 3. The only thing that multiplies to be 3 is itself and 1, so 3 is also prime. So, looking just at the ends of my branches, just at my prime numbers, I have 3 2's and 2 3's. I'm looking for my pairs. I have a pair of 2's. They get married, become 1, and leave the house. And I have a pair of 3's. They get married, become 1, and leave the house. This third 2 is sad. He's got to stay home. He stays inside my radical. And don't forget to carry down the number that was in front. 5 times 2 times 3. To simplify this, I can put this in my calculator. 5 times 2 times 3 is 30. And I keep my root 2. My simplified answer is 30 square root of 2. Another way we can simplify square roots is just by finding pairs. We might be able to find pairs before we get all the way down to prime numbers. Okay, 48 could be 4 times 12. And I know that 12 is 4 times 3. Notice here that 4 is not a prime number, but I already see pairs. So just like before, I can go ahead and write down what I have at the ends of my branches, 4 times 4 times 3. And just like before, my pair of 4's that match up, get married, become 1, they leave the house. So I write 1 4 on the outside. The 3 is lonely. He stays inside the radical. And don't forget to carry down the number that was in front. 2 times 4, I can simplify this. 2 times 4 is 8, square root 3. Notice, this is the same answer I got by breaking all the way down into primes. Let's try with 72. I could do 8 times 9 again, but maybe this time I use 2 times 36. 2 times 36 also equals 72. And I know that 36 is 6 times 6. Just like on the last one, I can see that I already have a pair, and 2 is prime. That can't be broken up anymore. So I can write down what's on the ends of my branches. 2 times 6 times 6. I carry down the 5 that was in front. My pair of 6s gets married, becomes 1, and leaves the house. The 2 is lonely. He stays inside my radical. On the outside, I can simplify. 5 times 6 is 30. And I keep my square root 2. Notice this is the same as when I broke it all the way down into primes. The last way that we can solve these is by being familiar with our perfect squares. Perfect squares are things like the square root of 4 we know is 2. Things that make whole numbers, the square root of 16 is 4. Square root of 25 is 5, and so on. So, I might know that 48 is 3 times 16. I know that 16 is a perfect square, and the square root of 16 is 4. 3 is not a perfect square, and it cannot be broken up anymore. It's prime. So I leave him in the radical. Don't forget to carry down the number that was in front. Lastly, I simplify what's left. 2 times 4 is 8. Root 3. Notice, again, I have the same thing. Okay, 72. 72. We can pick any multipliers that we want. Maybe I'll use 2 and 36 again. 2 times 36 makes 72, and I know that 36 is a perfect square. The square root of 36 is 6. The 2 is prime, cannot be broken up anymore, and it is not a perfect square, so it stays inside my radical. Don't forget to carry down the 5 that was in front. 5 times 6 is 30, and I keep the root 2. Notice that this is the same answer I got the last time I did these two problems. Any method you choose will work. You can choose any of these methods and get the same answer. So let's try a few. Number 3, we have 7 square root of 25. So you might look at this and think, oh, 25, I know that that's 5 times 5. And those are prime numbers. I have a pair. So that goes on the outside of my house, outside the radical. And I bring down the 7. There were no lonely numbers this time, nothing left over. So I no longer need a radical. My answer is just 7 times 5, which is 35. You might look at this problem and already know that, oh, 25 is a perfect square. The square root of 25 is 5, so 7 times 5 gives me 35. Whichever one of these methods you're more comfortable with will work. Okay, number 4, square root of 98. 98 is an even number, so I know that 2 can go into it. And if I use my calculator and do 98 divided by 2, this gives me 49. So 49 times 2 makes 98. If I was breaking this down into primes, I could say 49 is 7 times 7. There's a pair of prime numbers. It goes on the outside of my house. The 2 that was prime is lonely. He has to stay inside. So I have 7 square root of 2. Or, you might have seen this and noticed here, oh, 49 is a perfect square. The square root of 49 is 7, and the 2 stays inside the house. Both of these methods are the same. 3 square root of 216. 216 is an even number, so that means it is divisible by 2. 2 times 108. 108 is an even number, so it is also divisible by 2. 2 times 54. I'm not seeing any perfect squares yet, so I'm going to keep going. 54 is even, so it's divisible by 2. 2 times 27. Okay, 27 I know is 3 times 9. Oh, hey, 9, that's a perfect square. So already I know that my 9 is a perfect square, and the square root of 9 is 3. The numbers that I had left over, I had 2 2s that matched, and then a 2 and a 3. Don't forget about the 3 that was in the very front. From here I can simplify. Inside my radical, I see a pair, 2 and 2, that has to come outside of my house. I'm going to come up here. So now, outside of my radical, I have the 2 3s. The 2 that I just paired up, they got married, became 1, and left the house. And inside, this 2 and this 3, they didn't have a match, so they stay inside my radical. My last step to simplify is multiplying. 3 times 3 times 2 is 18. Inside my radical, since I still have 2 numbers, I also have to multiply these. 2 times 3 gives me 6. So my final answer is 18 root 6. 10 square root of 96. 96 is an even number, so it is divisible by 2. Two times 48 makes 96. (48) is 4 times 12. 12 is 4 times 3. I know that 4 is not prime, and it could continue to be broken up into prime numbers. But notice, I already have a pair. So I'm going to put my pair outside my radical. The 2 and the 3 are left over inside my radical. And don't forget to carry down the 10 that was in front. 10 times 4 is 40. Inside the radical, 2 times 3 gives me 6. My final answer is 40 root 6.